Hello and welcome to this lecture on the string class. Now, strings are the most commonly used class in Java. Now, very widely used. A string is an object that represents a group of characters. You may think of character arrays like in C and C++, but they're not exactly the same. Of course, internally they are character arrays, but the structure of a string class is a little bit different. Now, strings are also considered as immutable. So there are many API methods that help us deal with this string class. Now at the end of this video, you should be able to understand how to create string objects, understand what is called interned strings, use some of the common string API methods. Now string class implements immutable character strings. Now you might hear this term immutable quite often when it comes to strings. What is immutable? Immutable means the object's values don't change, which means if you have a string like name equals to Vinod and you call a function called name.toUpperCase, you might guess the value of name got converted into uppercase. The answer is no. What this function does is it creates a separate string, converts that string into an uppercase and returns that. So note that we have not stored the return value anywhere, so the name will still contain the original lowercase letters Vinod. Now in order to change that, you have to use name equals to name.toUpperCase. Now remember, the toUpperCase function creates altogether a new object and returns that, and that reference we are storing back in name. That means the original value which was stored is no longer available in the memory. In fact, it is ready for garbage collection, and when the next garbage collection happens, they get removed. So this is a new object. So strings, the original object never got modified. So these are read-only objects. Once it is initialized, they stay as it is. Now to work with dynamic character strings, such as for example, you want to change something to the existing object, you want to append to an existing object, or you want to reverse that in the existing object, you have a class called string buffer, and there is one more called string builder. They are similar in nature, but they can be used. Now this is an example of how do you create a string object, and we said string name equals to new string of Vinod. Now here a new object gets constructed because of the keyword usage called new. Now in the memory though, you can see name represents a reference variable, not a group of characters like Vinod. Now in Java, in C and C++, they would simply represent the actual variables and the values. But in Java, name is just a reference. And note that it is pointing to an object, and the object has some members. There is a variable called value, offset, count and hash. Now all these four variables are coming from the string class. Offset, count and hash, they are of integer type. Value is a character array. Now since arrays are objects, value is a reference, refers to another object, and that object is an array consisting of the actual characters VINOD, and then there is a public final field called length that represents 5. Now you may observe that the count and length, both of them have 5. Now this is because if count was not there in the string class, every time you are dealing with an end of the string, you have to go to that character array and find out that length. Now that is really a cause of a performance problem. And that's why what string class does is, string stores the length of the array in the count variable. And then onwards, whenever it requires, it uses the count variable, not the length, even though both are same. It's just a performance improvisation. So value is a character array, offset is 0, hash is 0. Now don't worry about what those two, but they are internal fields of the string class. None of them can be accessed directly. You can only access the string using some API functions or the string itself. Now let's see how to create and initialize strings. The easiest way to create a string object is to assign a string literal to a variable. Now string, unlike characters, use double quotes. So you should not use a single quote, because single quote is used for creating character literals, and this is a string literal. Now here the double coded text is going to be created as an object automatically, implicitly, and a reference of that is given to name. Now a string literal itself is a reference to a string object. So it is like a reference like name. So like name is a reference, double coded text Vinod is also a reference. Now the string literal on the right hand side of the assignment is a reference and it is assigned to a variable name which is an identifier. The both of them are references. So where is the object? A string literal itself can be used to invoke methods on the string object as well. For example, we can say int len equals to, we are using double coded text Vinod.length. Now this could have been like name.length as well. Like name is a reference, Vinod in the double quotes is also a reference. So we are using a reference of a string and calling a function, and they are same. So there is something called intern. Now what is it? The compilers optimizes the handling of string literals. The reason is string literals are the most number of objects that come across in the JVM. So compilers have to optimize that, and the way they do is by creating a cache of all these strings. Now only one string object is shared by all the string valued constant expressions with the same character sequence. Now at first it might look complicated, but it's very simple. Now these strings which are there in the cache is called as interns. Now the string class maintains a private pool where such strings are stored. So let's have a look at this. Now there are two variables, name1 and name2. Assuming that these are the very first statements that you are executing in a program, name1 equals to Vinod now is a reason for creating a string object. What compiler is going to do is to check whether this text Vinod is already there in the pool, the intern pool. If it is there, it's just going to give the reference. But initially, like I said, we are assuming that these are the first few statements, so that object doesn't exist. A new string gets constructed and stored in the pool. Now, when the second statement is encountered, now that object, the reference Vinod, is already found in the intern cache, simply gives the same reference to name2. Have a look at this one. Now, string name3 equals to, I'm using double coded text win plus a double coded text od. Now, since we are working on a concatenation of two string literals, this doesn't require a runtime. Compiler itself can handle this. What compiler does is, compiler does the concatenation, finds out that this Vinod is a string that's already found in the intern loop or intern pool, and that actually will be assigned to name3. Now, if you look at this pictorially, name1, name2, name3, all of them are referencing to the same string object called Vinod, but it's there in the pool. Now, let's have a look at this comparison. Since name1, name2, name3 all referencing to the same object, name1 double equals to name2, where we are comparing two references, that evaluates to true. Name2 equals to name3 also evaluates to true. Name1 equals to name3 also evaluates to true. Let's look at this one. String name equals to Vinod, or name1 equals to Vinod, and we have a part1 is only Vin. Now here there are two objects in the pool because we assigned without the new keyword. So there are two string literals, they both are placed in the pool. We have another name here, name4, and we said part1 plus od. Now remember, part1 is a variable. Its values are accessed only at the runtime, so compiler cannot handle this. Even though the part1 plus od becomes Vinod, it will be evaluated at the runtime, so this will now be false. Name1 double equals to name4 is going to be false because now at this part1 plus od is evaluated at the runtime, not at the compile time. This is also equivalent to probably something like this, new string buffer of part1, so that's going to be a dynamic string. To that od is added and then get converted into string. Why all these things are happening? And that's the job of the plus overloaded operator. So because there is a new string object over here, name1 and name4, they both are different. Now instead of assigning a string literal to a string variable, you can also use a string constructor. A string constructor is simply supply another string object or a string literal. So explicitly creates a new string object. Obviously, if you call this twice, they never get stored in the intern pool. So name1 equals to new string of Vinod, name2 equals to new string of Vinod. Both of them are in a different part of the memory. They both are different strings. Now, since strings are immutable, according to Java, this is a wastage of memory. We could have made both name1 and name2 are pointing to the same shared location because you cannot anyway change them. So name1 double equals to name2 will evaluate to false. So a reference to an intern string also can be obtained. That means if an object like the previous one is not in a string pool, you can bring them to the string pool using the intern function. Practically, we don't use this at all because most of the time we use double quotes. We generally don't use new string constructor. Let's start by looking at how do we read data from a string or how do we manipulate strings. Now, we know how to store a string object either by storing a reference of a double-quoted text or a new string constructor, but most importantly, we want to access the string that we stored. Let's begin first by looking at how do we access individual characters. So the function is caret and then we say index. So we are basically saying, hey, go to this index and give me the character at that particular index. Remember, index starts from 0 and it can go till the length minus 1. In case if you try to go beyond that range, then you get a string index out of bounds exception. And that's going to break the program execution. Now, there is also a function called getChars. And note that the method is void. That means it doesn't return anything. So what do? We specify the destination character array as the third argument. We say from where to begin, where to end, and where to store in the destination. So destination array must be initialized in advance. So here is an example of accessing one by one. Now we want to write a function called reverse that takes one input, gives the reverse of that. So the first thing we do is we declare one string variable and that's an empty string. You could as well use new string without any value in that. And then we use a for loop. Now note the for loop, the way we are working, we take one index, we start from the last index by saying input.length minus 1 and then we check in the reverse order. We say, hey, is this greater than 0? Yes, then let's reduce that. Now each time we reduce, we are accessing the last character, we append it to the rev. Now rev being an empty string, it gets concatenated with each of the character that you are doing. And once we are done, we have the reverse of that and we return this. Now let's look at how to compare strings. Now comparison can be done in different ways. You might want to compare two strings and check whether they are equal or not, but you also want to check, hey, is one string less than another string? Now you might be wondering how less than can help. Now two strings are compared lexicographically, meaning they're checked letter by letter, and as long as they are all same, it keeps checking 0, 0, 0, and then when two letters corresponding to the same index differ, it returns the difference value. Let's compare two strings, Shyam and Shailaja. Now when it is compared using the compare to method, S minus S results 0, so the comparison continues. H minus H is 0, Y minus Y is 0, but A minus L is a negative value. And since it is not 0, compare to will stop and return that negative value that was obtained. Whenever a negative value is returned, it says that this Shyam is lexicographically less than Shailaja. If you interchange and compare, now Shailaja is greater than Shyam lexicographically because S minus S, H minus H, Y minus Y, they're all zeros, but L minus A is a positive number and that number is returned. But if you are comparing Shyam and Shyam, then all 5 letters in individual positions, they're all same. The end result is also 0. Compare to will return 0. So whenever you're comparing two strings using compare to, you need to check for are they 0, negative or positive. Sometimes you want to check whether they are same or not. You can use two functions. One of them is equals And this is basically an overridden method from java.lang.object. You take an object, but assuming that they are strings, they are going to be compared. If it's not a string, it's obviously anyway false. But if there are two strings, they are going to check are they same or not. But unlike the previous method compare to, you cannot know which one is small or big. It just knows whether they are same or not. Now this is also case sensitive, which means if you have sometimes case insensitive comparisons to do, use equals ignore case. That takes a string as a parameter, not anything else. So you can't really compare string with any other object with this method. However, the return type is still Boolean. Now, there are some case conversion functions in the string class. Very simple. Two uppercase converts an uppercase version, and two lowercase will return a lowercase version of the string. Now, in case if you have a string called name1 and name1 equals to vinod.to uppercase is done, and note that vinod in double quotes represents a reference to a string object, and that reference is going to be used. Two uppercase will create a new object in the uppercase version and then returns that. The original strings are never modified because strings are immutable. Name2 equals to name1.to lowercase. Name1 still contains the uppercase version. It never gets changed because strings are immutable. The original strings are returned in case if there is no change required at all. For example, you have given name1.to uppercase, then there is no conversion requirement at all because name1 was already in uppercase. So actually the same string is written. However, a new string object is only constructed if there is a requirement of a change in case. This is what we say that all these string related APIs they are tuned to work in a high performance fashion. Let's have a look at how two strings can be concatenated, means joined. Now concat is the function. You take one string and supply to the original string and they get concatenated. But remember, the concat function is a member of string class and strings are immutable. That means the original string never get concatenated. You still have to assign that back to the original variable if you want the change. Now, concatenation of two strings results in a string that consists of characters from the first one followed by the characters of the second one. That is being returned as a new string. So it is also achieved using overloaded operator plus or plus equals to. That also can be used. So here is an example. We have a f name of Vinod and we have L name of Kumar. Suppose we want to create the full name. We create a variable called name equals to, we say fname.concat of a space in double quotes followed by a dot concat. So this is called statement chaining. We are calling a function and another function and another function. Now this is, if you look at the first part, fname.concat, fname represents Vinod, concat of a space basically makes it a 6-character string VINOD and a space. That is being returned as a reference. Now to that we are calling the concat. Now it is not to the fname. Now Vinod plus a space dot concat of Lname. Now Lname contains Kumar. Those 5 characters are appended to a new string along with Vinod and a space. So eventually you will have Vinod space Kumar. That is a new string that is returned and that is assigned to name. Now the concat method does not modify the original object because strings are immutable. Instead, the concat method returns a reference to the brand new string object because strings are immutable. Now let's see how to search a string within another string. There are many functions. There is an index of. Now index of is overloaded to take different types of parameters. Note that the characters are given in the int format. Now that's basically the Unicode value of the character that you are looking for. Now the return value is basically the index of a character if it is found. Now what if the character is not found? The character, if it is found, its index can be anywhere from 0 to the length minus 1. So obviously to indicate that the search was failure, it returns a negative value. Basically it returns minus 1, indicating that, hey, I couldn't find this character. There are variants of index. For example, you can say start for this particular character only from certain distance. So you don't have to really start from the first one. By default, it starts from the 0 index. You can also search for a complete string or string from a given index. Now, there is also a method called last index of. This time, actual search begins from the right side. That means from the end of the string, and wherever it is found first, it gives that, hey, this is the last appearance of that character. Once again, you can specify, don't start searching from the end, but search somewhere from the middle. But again, searching happens in the reverse order. You can also search for a string or a string from a given index in the reverse order. Now, there are functions to extract strings too. Now, if a string has some spaces at the beginning or at the end, you can trim that by calling a trim function. Remember, again, string is immutable. The original strings are unaltered. So it is always going to return a new string. Now, sometimes you might want to extract a part of the string. You can use a function called substring. Substring takes an index. From that index, including that character, it gets all the rest of the characters till the end, gives you a new string containing that. But what if you want a part from a specific index, some number of characters? Now here is an overloaded version. Remember, it is the beginning index and the ending index. In certain other languages, you will have functions like this to take the beginning index and a number of characters. Now here it is the beginning index and the ending index, and that's what actually this takes. Let's quickly summarize what we have seen in this video. Now, strings are immutable objects, meaning their original values can never be changed. If you really want that, you go with a string buffer or a string builder. Strings can be treated, or string can be created by just assigning a double-quoted text to a variable, or you can also use a constructor if you want. Many times we don't use that. Compilers optimize all the strings having the same values and being shared by multiple references. Now, this is done by what is called as interned strings. It's a pool of strings. Now, there are a lot of API methods that help in working with strings easily.